All right, so we're going to look at the four types of conics that we've covered in this section: the parabola, the circle, the ellipse, and the hyperbola. So, and each type has its own characteristics. So let's look at, there's a chart in your textbook that's given, and it talks about the different characteristics of the conic sections. So how to determine when you have a circle? Okay, well, the x squared and y squared terms have the same positive coefficient. Okay, so coefficient meaning 1. Okay, we'll look at 1, that's a circle. And then how to determine when it's a parabola, if it goes up, down, left, right. Well, if one of the terms is squared, either the x will be squared or the y will be squared, but not at the same time. So when to determine if a parabola opens up or down, then the x term will be squared, but the y will not be squared. To determine if the parabola opens left or right, either the y squared will be the y squared term will be squared, or the y will be squared, and then the x is not squared. Now, to determine if we have an ellipse, it says the x and y squared terms have different positive coefficients. And we'll look at an example of what that means. But the coefficients are positive. Look at the equation. You have a plus sign there between the x squared term and the y squared term. Whereas in a hyperbola, you have a minus sign between the x squared terms and the y squared terms. Okay? And either the x squared or the y squared term will be positive, or vice versa. Okay, so it says here how to identify if it's when it's a hyperbola. The x squared has a positive coefficient, but the y squared has a negative coefficient. Or the y squared has a positive coefficient, but the x squared term does not have, has a negative coefficient. So let's look at some examples that we have here. Decide on the type of conic section represented by each equation. To recognize the type of conic section, we may need to transform the equation. Well, for this example, we have x minus 2 squared plus y plus 3 squared is equal to 25. Well, what can you tell me about this? Because what I notice here is that the x squared term and the y squared term, they're both positive, and the coefficients to the x and y, they're 1. They're the same. And we have here where to determine if it's a circle, the x squared and the y squared terms have the same positive coefficients. So here we have a circle. Okay, how about B? X squared is equal to, x is equal to 3y squared plus 5y minus 6. What is being squared here only is the y squared term, so we have a parabola. Please change examples C and F to positives. So we have an x squared and y squared that are both positives is equal to 1. That's what we want. And remember that when both x squared terms and y squared terms are positive, we have an ellipse. Okay? And we have different positive coefficients, 25, well, 1 over 25 and 1 over 16. They're different positive coefficients. So here's an ellipse. How about D? What type of conic do we have? We have an hyperbola because the y squared, well, number one, we have a minus sign. And what's being negated is the y squared. E we will come back to because that's going to require us to do some changing of the equation. How about F? The x squared term, y squared term is a positive sign between each term. We have 1 over 9, 1 over 16. Though they're both positive, so we have an ellipse. G, y plus 7 is equal to x plus 3 squared. We have an x term that's being squared only. So this is a parabola. For H, we're going to have to convert this equation. X squared over 4 equals to 1 plus y squared over 9 so that we determine what type of equation we have here. And we're going to subtract the y squared to both sides. Y squared over 9 to both sides equals to 1. What type of equation will we have here in hyperbola? Because we have this minus sign between each term. For I, x squared is equal to 25 minus y squared. Let's add y squared to both sides. We have x squared plus y squared equals to 25. Both the x squared term and the y squared term is positive. And also we have the 25. This would be a circle. So now let's look at letter E, our last example. And we have here 4x squared minus 24x plus 5y squared plus 10y plus 41 equals to 0. So let's transform this equation where we're going to complete the square. So let's bring together our x terms, leave some space between the x terms and the y terms. Plus 5y squared plus 10y equals to, we're going to subtract 41 to both sides. So we're going to complete the square. But before we complete the square, we're going to, for the x terms, we're going to factor out the 4. We have x squared minus 6x. And then for our y terms, we're going to factor out the 5, and we have y squared plus 2y. And let's not put the parenthesis there just yet. We're going to put it here, equals to negative 41. So what I want us to do is complete the square, fill in the blank here. Okay, so as we complete the square, we're going to take half of the middle term. So take half of 6, the coefficient of the middle term, half of negative 6, squared, we have negative 3 squared, which gives us 9. So we have plus 9 here. But remember, when we complete the square, what you add on one side, you have to add on the other. But we have this 4 that's outside this parenthesis here. So what you're going to do is take this 9, because had I had you to distribute this 4 to every term, we would have to multiply the 4 to the 9. So we're going to add, we're going to add 36 on the right hand side, because 4 plus 9 gives us 36. Okay. Then let's do the same thing to the 9, to this 2. Take half of 2y, or 2, the coefficient, squared. We have 1 squared, which is 1. We're going to add 1 to both sides, and then times that 1 to 5, and we have plus 5. Okay, so Then on the left-hand side, let's write the trinomial as a binomial squared. So we have here 4 times x minus 3 squared plus 5 times 1 plus y plus 1 squared equals to, look at the right-hand side. When we add those together, what would that give us? A 0. Okay. And if you notice, whenever we have an equation such as this, um, we never had, at least we haven't come across one where 0 is the solution or equal to 0. So I know it's not an hyperbola, it's not a parabola, it's not an ellipse, and not a circle. Because in order for it to be a circle, it says the coefficients must be the same. And if we distribute this 4 and 5, the coefficients are not the same. So we would say is neither of the choices that we have here. Okay, so that one is not a conic. It actually will be a point, and we can't do anything else with that one. So we are finished.